Hey everyone, welcome back to the channel. This is Rahul. So in today's video, we are going to start with sliding window. So you might be heard of this term sliding window when you come to interviews or something. In today's interview sessions or lead code problems, sliding window is one of the important concept because it will help uh, the program or the code to work in somewhat efficient manner when we compare to other approaches like brute force. So because of that reason, most of the interviewers will ask regarding sliding window and they will ask questions from that. So it's actually used when we work with subarrays like as you know, when we have a string or when we have an um, array, we need to if we need to continuous part of array like that, it's subarray or substrings. When it comes to string, instead of recalculating every time, here what we are doing is we will fix one window, like we will set a boundary in the left and right part, then we will process it. Then what we are doing is we will slide the window by one step, like we will leave the left element and we will add the right element, like that it's work actually. I will just show you how it's and all. So just see, this is like a part. Now one, two, three, four, five. Now just imagine the portion that you can see at the first time is this one, this two, and this three. Okay, so here the boundary that we have is from 1 to 3. Alright, so what happens next? Rather than processing each substring like these, these, like that, means uh, recalculating every time, what we are doing is first we will process these three, then we will take the what is outcome, whatever the outcome we will take it. Then once this uh, range process, then what we are doing is we will leave this first one, right? Then we will go for the next one, which is the fourth, right? So the next array, next one will become 2 3 4. Fine. Then here what's happened, we left our 1 and we added our 4. Then again we will go for next till the end of the array. We will uh, process and we will take the outcome. Then we will check the differences, like that it's happening. So this will avoids the redundant work and reduces the complexity that the work takes, like that it's happening. Now I will just mention one of the real world example, like it's actually a common thing that you may also know. If you if you are traveling one traveling person, then you might know what this means. When you travel in a bus, you see only a fixed view when you are at the window side of the bus. Okay, whatever window means bus, car. Okay, then what happens as the bus move? This is the process it's happening as the bus moves. Then the window slides, like it will leave the past thing and it will add the next one. It will leave the left and it will add the right. Same thing happening in coding also. Instead of recalculating all the views, we will drop the one that we already found, the one that we that is at the left, and we will add the new one at the right that we just reached. So this is the thing with respect to sliding window. This is the concept. Just processing the uh, data within the boundary. Then once it processed, then we will leave the left element and we will add to the right element. This is the process. So there is two types of sliding window. Okay, first one is fixed size window. Okay, second one, variable size window. Okay, so fixed size means it's nothing but the window size is well known. Okay, which means the one of the question that showing fixed size is maximum sum of subarray of size k. Like that question, you can focus on fixed size window. Next one is the variable size. It's, as the name mentioned, window grows or shrinks dynamically until a condition is met. The one of the example question that with respect to variable size window is smallest subarray with sum greater than or equal to target. So these are the two questions with respect to um, uh, types of sliding window. I hope you understand the concept. Now we can just check how this actually works. So I will just show you the brute force approach and the um sliding window approach for same question. Okay, the one of the question that we are going to do is find the maximum sum of any subarray of size k. Okay, so for this I will take a input, means not like a scanners, just from my side only I will give, and I will use window size of 3. So int array 2 1 5 1 3 2. Okay, let it be the data. Now the window size be 3. Okay, this is the thing, we have to find the maximum sum within the window size 3. So what this means, so the window size can be 215, sorry 3, so the data can be 215 or 1511, 151 or 513 or 132. So this way, this is the pattern actually it's going. Okay, now to find the maximum sum, first of all we need one variable to store the maximum sum that we get from this subarrays. Int maxsum. Now in this is the uh, brute force approach. Okay. Now what we are doing is we will loop through all starting point of the subarrays. For int I0 I less than or equal to array dot length minus k, then increment I. Because of the subarray we are doing in this way. So here we will calculate the sum of current subarray of our size k. For that I need one variable. Then again we are looping. Sorry, j equal to I, j less than I plus k, then increment j. Okay. So here what it's doing is it will just uh, whatever in the subarray it will just add it. So sum plus equal to array of j. Okay. Now what we have to do is we have to update the maximum sum. If this is the maximum sum, then we have to update it to here, or we have to use the maximum 0 only. So for that we will use the inbuilt method of math. Okay, now we can print it. Maximum sum. Okay, so this is the thing. When we come to brute force, we have to loop two times. One through the entire array, next through the subarrays to fetch the sum. So you can see our maximum sub is 9, right? So what happening here is uh, we have the window, right? Then mm, okay, we have the window, sum, and max. Fine. Now we can okay, we have the data. Uh, so this is the data 215132. Okay. Now what happening here is first it will go for 215, then it will go for the sum 2 plus 1 plus 5, which is the 8. At that moment the maximum is 8 only, right? Same it will go for the next one. So now it's left 2. Next is uh, Okay. Next is one. Sorry. 151. Okay. Now the sum is 7. When it comes to max, it will compare 8 and 7 and it will go for 8. Next, it will go for 5, 1, 3. Again, it will go for sum. Now it's 9 and the max will change to 9 here. Then it will go for 1, 3 and 2. Now it's 6 and max, sorry, changed, no change, 9. So in this way it will loop. Like first it will travel through all this data, then it will take the subarrays, then it will process. Like that in brute force we are doing. So because of this the efficiency becomes weird. The time complexity becomes big of n into k. Okay. Like the based upon the window size it will vary the complexity. Now we can go for our sliding window approach for the same one. So I just want to remove this much only, because anyway I want to uh, print this. Okay, I will remove this one as well. Okay, fine. So same data, same window size, fixed window. Now what we have to do is, first we need to compute the sum of first window. For that I need one window sum. So int is equal to 0. Okay. Now I need to traverse through the array. For int I is 0, I less, sorry, I less than k, I plus plus. Okay. So in this we are not doing nothing but just we will fetch the sum, array of I. Okay. So we have the sum now. Now we will go for max sum, which we will assign the value of window sum. Okay. Now what we are doing is we will do the sliding window approach. So in this part we will add the new element and remove the leftmost element in the particular window. I is equal to k, I less than array dot length plus. Okay. Now we will uh, go for the mm, a sliding I minus k. Now we will get the maximum sum. So same approach, but rather than going for nested loops, we are finding the sum first of the particular window. Then we will get the maximum sum. See, same only. This is sliding window approach. Okay, here it's actually doing nothing, but it will first calculate the uh, first element. Sorry, sum of first k elements, that is the first window. Then for every next element that's happening here, for every next elements, it will add the new element to the right side and remove the leftmost element, which is we are ignoring out the window. Then we will update the maximum sum. So this is the thing happening in sliding window approach as well as in brute force approach. Here the time complexity is big of n because we are doing only traversal ones rather than going nested loops. Okay, so this question, this maximum subarray question is actually uh, we did with respect to the fixed size window. Next one is like variable size window question. For that we can use the smallest subarray length with sum greater than or equal to target. Okay, so for that also we can uh, start. So in the subarray, small subarray length with sum greater than or equal to target question, uh, target. Okay, here uh, we are using 2 3 1 2 4 3. Okay, and let be our target 7. Okay, so here what we are doing is we will uh, same we will keep it as a window at first. Then when the condition met, we will do the stringing. like that we are doing in uh, this variable window approach. Okay. Mm, fine. Okay, let's start. First of all, we need to set the uh, boundaries like the left and right. Int left is equal to 0. Then we need the sum 0. Then we need to get the minimum length. So for that we will do use the max value. Okay. So you might be thinking like we given left, so why didn't we start with right? So for that we will use it in for loop. Int right is equal to 0. Right need to less than the array length. Then increment right. Now we need to add the data to our variable sum. Okay, once this done, what you have to do is like means, which means once the condition met, when we have to try the stringing part. So here it's nothing but we are expanding the window by adding, sorry, right element. Okay. Okay, now we need to set the condition while sum greater than equal to target. Okay, then we have to update our minimum length. Also we have to string our window. Min length is equal to mat dot min length. Okay, we have to give this condition inside our for loop only. Right minus left plus 1. Okay, so once that's done we need to shrink our left. And we have to go for the next one. that it will happen in our loop. Now we need to go for the smallest length. Is equal to integer dot max value, then 0 or min length. So you can see the smallest length is 2. Okay, so I will show you how it's happening. Okay, so uh, we have our data. I'm just taking this. Okay, so integer array 231243 and target 7. Fine. Now what happening is we have the left, then right, then window, sum, and minimum length. Fine. So at the left there is starting, both are 0, because as you see we assigned left 0 and right are 0. Then window at that position is 2, and the sum as well as it's 2 only. Minimum length nothing. Okay, then left is 0 because the condition is not at met, right? Now we will move forward. Now our data is 2 and 3. Okay, and our sum is 5. Again it's 3. It's nothing because the condition is not yet met. Now again 0, it will go for next 2, 3, 1. Now the sum is 6, so no change. Again 0, 3, 2, 3, 1, 2. Okay, so here as you can see the sum exceeded the target. Okay, so what happened is once the target achieved, it will update the minimum length. So the array size is 4, so the minimum length will update to 4, right? Now once this done we will increment left. We have 3 as the right. Then we will go for the next part. we left 2. Next is 3, 1, 2. Okay, which is 6. No change. We will go for next in right. 3, 1, 2, 4. That is 10. Okay, so now no change here. Means we have the length. We achieve the target. Okay, now we will update the left. 2, 4, 1, 2, 4. Okay, it's 7. So now the size is 3, right? So it again change 3, 4. So now it's 2 and 4, which is 6. So no change. Now it's 3 and 5, which is we already reached our last 2, 4, 3. Okay, which is 9. Now it reached, so the part is 3, but it will get to 2, like same happening all here. Sorry. So in this way we are getting the output 2. So this is the method it works, like the sliding window approach works. Once it in the variable size condition, in the fixed size it will go like if the size is 2 3, then it will go for next 3 1. When the size is unknown or we don't have any fixed size, we will use this method, like since once the target achieved, we will go for next. So this is the way that we are doing sliding window approach. Some common application that using sliding window is like maximum minimum subarray, then longest substring with or without constraints, then count distant elements in window, data stream analytics, then network packet monitoring, also DNA sequence substring analysis. Some even though some common mistakes that most of the people doing is like once we fetch, as I show here, I will show you here some mistake that happening when we do sliding window is uh, here, if we once we met this condition, if we forget to shrink uh, the window, that is, that will lead to infinite loop, or it will lead to wrong answer. Next one is without handling the edge cases during exam time, or uh, like lead code challenges, there might be constraints in a contest. So at that time, if we not care about these constraints, it will leads to TLE like issues. During the other times it's okay, during contest they will put these type of things. Also handling the empty array. Then another one is assuming the sliding window works for non-contiguous, but just remind it's only for contiguous uh, it will work. Then updating result outside the loop incorrectly. These are the issues that we will face with respect to sliding window. The common mistake that will happen. Okay. Now we can go for one uh, question in lead code, which is the longest palindromic substring question. So here, what we have to do is we need to return the longest substring, longest palindromic substring in the string S. Okay, here as you can see, we have BABAD. In this, BAB also there, ABA also a valid one. So it's just taking any one in this input. Here CBBD. Here the valid one is BB only. Okay, and you can see the constants and all. It's okay when we are doing here at this moment. Fine. So I'm not going for brute force approach right now. That you can check via internet how brute force approach work in this one. So in this, what happening is, uh, as you know, every palindrome is defined by its sender and symmetric expansion. Like odd length palindrome. This is one odd. Okay, means the size is 5. Because of that, it's odd. So if you see here, we have a single sender, right? When it comes to even length, palindromes have a gap sender. That is, when we see here CBBD, thus it's centered between two uh, B's, right? So for each index I, we need to expand around I for odd palindromes, and we need to expand around I plus 1 in case of even palindromes, which take the uh, longer of the two. So when it comes to complexity analysis, the worst case that can happen is big of n square. But when you comes to brute force, it will go beyond. It's like a big of n cube. I think the yeah, big of n cube, the time complexity. So this is the good approach compared to brute force. Okay, now we can do the coding part. So for this, we need to use one helper method which will expand while the left is equal to the means the date. I'll just show you with this example. Like if the right data is equal to left, then we have to return the palindrome string. For that, we need one uh, helper method. So let's start. Private string expand helper s int left int right. Okay, now what we are doing here is we will expand the outward as long as we are in bounds and characters match. For that, we will use one while loop. While left greater than equal to 0 and right less than the length of the string and char at the left is equal to s dot char at right. Okay, so this is the condition we are mentioning. This is the main one. The caret left needs to caret right. Then we will move. We will move left pointer outward minus minus. Then we will move right pointer outward, which means to the right. So we will increment right and decrement left. So now we will stop after going one step too far on each side. So the valid palindrome is left plus 1 to right minus 1. That is substring of left plus 1 and right. Okay. So we have to return s dot substring right. Okay. So this is the helper method which we are using. Now we can go for our main part where we will go for the edge cases. Like first we will go for empty or single character edge case empty or single, yeah, if yes is equal to null or length less than 2, then nothing, we just need to return our string. Okay, now we need to find the uh, longest one. For that we need one string longest. So here what we have to do is we need to consider each index as the sender. For that, for int I is equal to 0, I less than length I plus plus. Okay, fine. Now what we have to do is the first one, odd length palindrome. Okay, so case 1, when it's the odd length, as I already mentioned, for odd length the uh, we need to expand around I. When it becomes even, it will become I plus 1. Okay, so it's for the odd length. Hmm? And it will be sender at the I. So string odd is equal to expand. We will call our helper method here is I. Okay, this is the first one. Next, our second case, that is even length. Okay, here the sender will be between I and I plus 1. Fine. So string even is equal to same, we have to call the helper method is I plus 1. Okay, now we need to pick the longer substring that we get from this length. If odd is the one, we will pick odd, else we will pick even. Now we need to update the global longest if needed. If bus1 dot length longest dot length, then we will update. It's not necessary actually, even though. Okay, now we need to return the longest. Fine, can run the code. Hmm, what's happening here? Hmm, okay. Yeah, it's working fine because of this spelling issue, and here we forgot to add parentheses. We got the error. Yeah, it's working fine. Now you might be thinking why we add the substring left plus one and right, isn't it? So after the while, uh, we will move one step too far on both side, either hit mismatch or a bounce. So the last valid palindrome ends at the right minus one, and it will start at left plus one. So in Java, a substring AB returns AB. So the substring will be left plus one right, which is the perfect cast. So this is the thing with respect to sliding window. If you have any query regarding this, you can ping me. I will help you. So till that, see you in next video. Happy coding.